wanted to talk a little bit about momentum. Momentum is a mass times a velocity, right? So mass times a velocity. If you have a big mass, you've got a lot of momentum. If you've got a big velocity, you've got a lot of momentum. So a small particle moving really fast has a lot of momentum. A big particle moving really slow has a lot of momentum too, and a big particle moving really fast has a tremendous amount of momentum. So momentum is kind of an interesting segue into our next segment, angular momentum. People really don't have a grasp on angular momentum the way they do on momentum. Well, angular momentum is the same thing. It's a mass times a velocity, but now it's moving along a radius. And this is spinning. It's an object that's spinning. It generates what's called an angular momentum. And I've got some interesting demonstrations that I'd like to show you. So stay tuned. We'll be back in a couple. Hi, thanks for coming back. I talked a little bit about momentum, angular momentum. Here's an interesting way to look at angular momentum. Angular momentum, capital L, is a mass times a velocity times a radius, but it's also a moment of inertia times an angular frequency, the spinning rate. That's the angular frequency. Well, I've got some interesting things to talk about with angular momentum. One of the things you need to know about angular momentum is moment of inertia. Here I've got two masses. I'm sitting in a chair that can rotate. So we talk about rotational motion here when we're talking about angular momentum, spinning around a circle. Here I've got a big moment of inertia because I've got these two masses widely apart from each other. I'm going to spin myself and see how fast I spin. This is my spin rate or angular frequency. Okay? Not really fast. What happens if I change the moment of inertia? Well, we said if you have a big moment of inertia, you have a smaller angular frequency because it's equal to the angular momentum, thing called conservation of angular momentum. You can't have one thing be bigger and the other thing be bigger as well, meaning angular momentum is conserved, so you can't have angular frequency and moment of inertia increase the same way. One decreases, one increases. So if this is big, my rotational frequency must be smaller. If this is small, my rotational frequency will be bigger or faster, and I'm going to show you right here. Here we go. Ready? Here, a big moment of inertia, smaller angular frequency, small moment of inertia. Watch me spin really fast, big angular frequency. Here we go, and whoa! So a big angular frequency with a smaller moment of inertia. Smaller angular frequency with a big moment of inertia. Let's try that one more time. By the way, watch out. You get dizzy doing this. So here we go. Ready? And whoa! Just like the skaters do on the ice. Ooh, getting a little dizzy. So, moment of inertia, kind of interesting. Well, we need to also talk about center of mass. Yes, objects spin about their center of mass. It doesn't matter what the object is. Here we've got a dumbbell. I've got a little string attached to the dumbbell. Let's see if I can balance this here so that it fits right in its center of mass. Watch what happens when I spin it. Yes, the dumbbell, no matter where it goes in space, spins about its center of mass. So all objects spin, but they do so about their center of mass. So it's important if you're a juggler, and of course I'm a juggler. You've probably seen me juggle before. I'm going to juggle. In fact, while we're doing the dumbbells here, let's do some dumbbells. You ever see anybody juggle dumbbells? Well, try not to do this with 30-pound dumbbells. Let's see what we can do, but we're going to spin them about their center of mass. So here we go. Whoa, whoa, whoa. Well, not as easy as you might think. Got some other things to juggle here. Jugglers like to spin pins, all right, or clubs, I should say. They also spin about their center of mass, and yes, you can kind of balance the juggling pin here on near its center of mass. Whoa, Kind of hard to do. There you go. And that will spin about its center of mass. So here I'm going to juggle these clubs, juggling pins they're called, and they spin about their center of mass. So as you can see, really important, especially if you're a juggler. I'm going to juggle some other interesting stuff. Here are some little plastic-like dumbbells. Doesn't matter how long they are, they're all going to spin about their center of mass. So here we go. Oh! That's a tough one. A little bit easier than the dumbbells, because the dumbbells don't have as long a... Oh, there they go. So, oops. Now what about plates? You can spin plates too. They also have a center of mass. These plates, their center of mass is right in the center of the plate. Holidays are coming up. I think it's 4th of July coming up. Boy, I could use some cool watermelon. Let's juggle some cool watermelon here. They're all going to spin about their center of mass. Oh, there they go. And up and whoa! There they go. Cool watermelon. Well, by the way, talking about 4th of July, you got to have your hamburgers, your hot dogs. They're delicious. I'm going to have a few here and juggle. Oh, we're not spinning them, but they're certainly good to eat. And then finally, oh, I can cap that off with a little cool ice cream. Let's see what I can have with the ice cream. Oh, some delicious ice cream. Ooh, I'm going to really enjoy this. And, oh, just my luck.